Okay, so in this video, we are going to talk about annuities payable more frequently than interest is converted. So interest is calculated. So the idea would be it is same like the previous section we talked, where the annuity is payable less frequently than interest is convertible, but now we have interest payable more frequently. Okay, so let's say this is your interest payment period. Let's say it's 0 to 1, and then you may get payments frequently than the interest is calculated. So you can divide this, like, let's say you get M payments. Okay. Um, so this is maybe, let's say 2 over M, 3 over M, so counting, then this one becomes M minus 1 over M, and this basically M over M, which is 1. Okay, so then you can have another interest payment period 2, and then you get payment in between. Okay, so these are payments, and then at this point you get interest calculated. Okay, so payments are more frequent than interest is convertible. It's the opposite of what we learned in previous section. So now again we want to talk about annuity immediate and annuity due. How do you calculate the present value and future value? Now for this one we have special symbol. You will see something like AN IM, okay, and then SNIM, and then a double dot NI and S double dot NI. So you will see different, little bit different symbol. In previous section there were no you didn't see any new symbols, but in here you will see new symbols. Okay, in the last section we considered annuities whose payment period consisted of several interest period. Okay, so payment period consists of several interest period. So what that mean in the last section, okay, not this section, last section, we talk about where payment is less frequent. Okay, so basically you had something like this. We use the K. So in between you have a K interest conversion before the first payment. Then again another K interest conversion before the next payment. Okay, so forth. So now it's a little bit different. So in contrast, in this section, we focus on annuities whose interest period is made up of multiple payment periods. Considering a level annuity, again, it's level annuity. Even the previous section, we would consider level annuity. And lasting n interest period and paying 1 over M at the end of each mth of interest period. So that's a little bit different, because last one we didn't talk about different payments. So in this one, it would be 1 over M. Okay. So in this diagram, you can see the payment amount is 1 over M. So when you sum up, it's going to be 1. Okay. So this is interest period. And then total the payment would be $1, but it's going to be paid M time during that time period. Okay. The same for the next one. As previously noted, this annuity has payment totally 1 each interest period. We introduce the new annuity symbol for present value of this annuity, and this annuity symbol for accumulated value of at the time of the last payment. Okay, so now we need to know how to calculate. We want to know how to calculate the present value. So one approach would be you calculate the effective interest period for this small time period. Okay. So let's take this one. Okay. So you have interest period 1, no? So let's assume, let me go to the next slide maybe. Yeah, so it's from there. Let's assume, I denotes the effective interest per interest period. It can be 1 year, it can be 6 months, it can be 1 month, but whatever this interest period, let's assume the effective rate is I. Okay. So from there, you can calculate the effective rate for this small time interval, 1 over m. Okay, so how do you calculate that? Let's say the J, so J is the effective interest rate for the payment period. Okay, so J is the effective rate for payment period. Okay, so this one is for interest calculation period. This one is for payment period. So now let me draw the timeline. So you have 0. This is 1 over m. This is 2 over m. This is m over m, which is 1. For this entire time period, your effective rate is I. Okay. Then for this small time period, that's what I want to know, the J. Okay. So here you are getting payment 1 over m, 1 over m, 1 over m. So how do you calculate this J? We know that 1 plus J to m should be equal to 1 plus I. So from there, J equal what? 1 plus I to the 1 over m minus 1. So now, for me, it's look like what now? I have 1 over m payments. And how many payments? You have m time n payment, no? So number of payments, number of 1 over m payments. If so the n is the total interest period. Okay, so if n is total interest period, so for each period you are getting m payment, no? So per interest period, a number of payments are m. So then for the n interest period, total would be mn. So total payment would be mn. Okay. So you are getting 1 over m payments mn time. Okay. So 1 over m payments mn time. Okay. So we can use our usual approach. So I can write present value. What's the payment size? 1 over m. What is the time? How many payments? Nm. And what's the rate for one of those payment period? It's going to be J. So this would be one of approach you can easily use. Okay. So what we did, we calculate the effective rate. That's the key part. Okay, this is the key. You calculate effective rate per payment period. Okay, so from I, you calculate J. I is for effective for interest. Whenever we are using effective, you have to be careful. Effective for what time period? Okay, so for interest period. Then the J is effective rate per payment period. Okay, so from I you get J, then you can readily use this a nice formula to get the present value. Once you know that, you can calculate the future value too. Okay. Time we know what to do. 1 plus J to how many are there? Nm. Okay, so we can get the future value. So that is one approach. So from there we can really prove a few other formulas. So let's come to this one. So this present value, there's another, instead of PV, I can write the symbol wise. Let me, I want to introduce a symbol. So this is called ANM, and I can use the rate I. Okay. That is same as 1 over M ANM J, where J is given by 1 plus I to 1 over M minus 1. Okay. So this is basically present value. Okay. The symbolically how you write it, that's the way. Okay. So whenever you look at this, what this mean? This means basically M payment period, M payments per interest period. N is number of interest period. So basically that means M over N. And then the payment size, that's also hidden here. You don't see 1 over M in front of this. Payment size is 1 over M. Usually it's $1, but when we use this symbol, it's going to be 1 over M. And then the I is effective rate per interest period. So everything hidden in that symbol. Okay. So that's same as this one. Here you don't have M, okay? No M. Like this symbol, okay? It's not there, okay? So don't write that up. It's same, okay, but the value is same. Okay, so I have this formula. 1 over M. I can expand it. What do I get if I expand it? If I expand it, oh, by the way, let's try to get a formula. Maybe let's expand that one. Later I will come back to this. It is 1 over M. So what is this? This means basically 1 over M, 1 minus V to the NM over J. And what is V in here? You need to be careful what V mean in each. Every time when you see V, you have to be careful what V mean. Okay, so V mean basically 1 plus J to the power negative 1. Okay. So this one I can write as 1 over M. What can I do? I want to do something. Let me see. I can try. One plus. So let me substitute in V. So 1 plus J is what? 1 plus J is basically 1 plus I to the power 1 over M. No. So this is basically 1 plus I to the 1 over M. Then you have negative 1 outside. So that's basically 1 plus I to negative 1 over M. So let me replace that in here. And then let me leave J as it is. Okay. So then in here, it can be simplified. You can see M to M cancel out. So I would get 1 plus R to negative N. Then here I have J. So so the top part, I can write like this. Okay, this one I can simplify a little bit more. I can write like this, like 1 minus 1 plus I to negative N over I Then since I introduce I would write like this. So this is what? This is basically annuity du, annuity median in I. Then you have I over j. Okay. So what is j? This j we are calculating. What is that? What's the real name? So I have 1 plus j to m equal 1 plus 1 plus I, no? So this is basically, if you look at this one, this is basically what? Im divided by m, no? So this is, if you look at this, 1 plus Im over m to m, because this is nominal rate divided by m, this entire thing. Okay, that's what j. So I can replace this j by Im over m. Okay, so here I can write 1 over m I, and then this one by Im over m. That would cancel out this m to m, and you would get a n I time I over Im. So that's the first result in here. This result. Then you can multiply. So once you have a n m, you can multiply it by 1 plus I to the n to get the s n m future value. Okay. So this part would be same, but then a n I time. So this is same as what? This is same as a n I over Im. Then you have multiplied 1 plus I to the n. So these two terms simplify to s n I and I over Im. So you get to that one. This one we already proved. This j here is, here you can see Im over M. This need to be right like this, Im over M. Okay. So for the same with this one. So those are the proof for that for formula you can see. So now we can kind of like replicate the same results for annuity du. Okay, same idea, only difference is your payment start at the very beginning compared to the previous setting where first payment start at the end of the 1 over m time period. Okay, you are still getting more payments than the interest convertible. So m payments per interest period. So you use the symbol, same symbol, but with double dot over a and double dot over s. And here you can find the formula. It's pretty much same like this, but as usual, instead of I, we have D. Okay, so now let's do some problem. So here you can see the what happens if you have perpetuity. Okay, if you have perpetuity, let me go back to this formula. Okay, in this formula, ANM is what? ANM uh, 1 over M ANMJ, no? So 1 over M ANMJ, which is 1 over M 1 minus VM over J. When n goes to infinity, this term goes to 0. So when n goes to infinity, 1 over M, 1 over J. But J is basically Im over M. So this is cancelled out. You end up with 1 over Im. So that's what happened if you have perpetuity. So on these two formulas. The next one you can try yourself. Okay. So here you can see a relationship. A and I is smaller than A and M, is smaller than this one, and which is smaller than that one. So these two are in the end, left and right, and then in between you have this. Of course, if you remember, a double dot Ni is 1 plus I time ANI. So right away, this prove that a double dot N, because this one you are multiplied by more than 1. So it's bigger than ANI. Okay. So then the rest, you can try to prove why this relationship hold. Okay, so let's try to calculate this quantity. Now, whenever I see this one, my favorite formula is this formula. Okay, it make calculation really easy. So this would be what? This is 1 over 12. So your M is 12. A 12 times 48 under 8J. Where what's the J? 1 over J to the 12 equal 1.05. Okay, so you have to solve for J. So let's calculate. Let's get the J. So what do you get? Let's say 1.05 to 1 over 12 minus 1. So your J is 0.004074124. And then now for this one, I can calculate this quantity. Okay. Or if you want, really, you can enter this one too. So you can use a calculator. You can say payment is 1 over 12. And number of payments is 12 times 48. Compounding per year. When we use this one, you are thinking that 1 over M is effective interest calculation period. So this would be 1, payment per year would be 1. Okay. And then the rate would be J. Okay. That's the setup all the time if you use this formula. Okay. This would be exactly look like this. What else? We need future value is 0, and we can calculate percent value using our calculator. So let me use our calculator and see what we get. So second is it. So I'm entering 1 divided by 12 to payment. Then 12 times 48 to N. Then the rate, let me check the rate. You have to enter this as percentage, okay? Not decimal. Remember, in the calculator, you are entering percentage. So your rate is 0.74123 for I. And second IOI payment is 1 components. Wait. And 0 for future value. And complete percent value. And I would get 18.49. So that's the percent value. The same setup for this one, but only thing is set calculator due. Okay, remember that. Sometimes yes, that's a big mistake we do. Okay, let's go to the next problem. Shirley invest 200 at the end of each quarter for 8-year in the account having an annual rate of 4%. Fund Shirley's accumulated value at the time of her last deposit. So invest 200. Let me draw the time line. Each quarter. So 1/4, 2/4, 3/4, 1. Then 1 and 1/4. Okay, so you can see the payments are more frequent than the interest converted. I mean, interest calculated. Okay. So let's, how do we do this kind of problem? This is basically what? So you have payment of 200. Okay. So I can enter calculate actually. If I know the rate J, let me calculate plus J. That make this entire calculation easy. Um, so your J is what? Your J is going to be 1 plus J to 4 equal 1 plus I. So J is basically effective rate for this time period for per quarter. Okay. So 1 plus I, 1 plus J to 4 equal 1.04. From there, you can get J. Okay, let me get the J first. So this is 0.985334%. Okay, so now I can use calculator. So how many payments? For 8 years, 4 times 8 years, that's 32. What's the payment size? 200. And then what's the present value? That's what we want to, no, present value is 0. Future value is what we want. And the compounding per year is 1. Payment per year is 1. Okay, you have to set like that. And then the rate is always J. Okay, so IOY is going to be J, which is 0.98534. So let's solve this. Let me use the calculator. So second, this one is at the end, no? I think it's annuity immediate. If I remember the problem. And second reset. Okay. So 32 payments. 200 the payment size. 0% value. 0.98534. Payment per year is 1. Compounding per year is 1. Second quit and compute future value. 7,481.05. That's the future value. So in this one, a loan of 3,000 is to be repaid with quarterly installment at the end of each quarter for 5 years. If the rate of interest charge is 10%, convert semi-annual, find the amount of each quarterly payment. So 0. So we have how many years? 5 years. Payment is 3,000. At the end, so it's annuity immediate. Okay. Now the rate is 10% converted semi-annually. Okay, so we are given actually what? We are given I2. So so nominal rate. Okay. So then what's the effective rate for 6 months? Effective rate for 6 months is going to be I2 divided by 2, no? Because this is nominal rate for year. Then effective rate for 6 months is 10 divided by 2, which is 5%. But what do we need? We need J for quarter. So I can see 1 plus J square, not fourth, okay, square, because we are having effective rate for 6 months, not for year. So this should be 1.05. From here, I can get J. Okay, so this is effective rate per quarter. Okay? So let's solve this. 1.05 to the 0.5 minus 1 multiplied by 100. I get 2.46. as percentage, 2.46950,766 percentage. Why percentage? Because that's how you enter to calculate percentage wise. Now I can use calculator. So how many payments? 4 times 5. Payment size 3,000. Effective rate per payment period is now 2.46950,766. This is IOY. When you use this method, you set COY and POY both to 1. Okay. Then loan of 3,000. Wait. So this one is 3,000 present value. Okay. Oh, no. So we want to find the payment. Okay. So future value is 0. Present value is 3,000. The loan amount right now value is 3,000. Oh, lucky I did. Otherwise, we would have made a big mistake. Okay, so let's solve this using our calculator. Let me bring the calculator. Let's reset this one. Second reset. Enter. And I would enter. So there are 20 payments, and 0 is future value. 3,000 is present value, and then the rate is 2.46950,766. Second, this one is 1 and 1, just to make sure. Now let's complete the payment. So complete payment 191.89. Okay, so payment is negative because you had to pay. Okay. So payment is 191.89. Okay. What is the accumulated value of following the last payment of 100 at the end of each month for 30 years into an account that earns an effective annual rate of 10%? So, so here is the timeline. 100 deposit at the end of each month for 30 years. Okay, so it's end, so annuity immediate. So end of each month, so you have 12 payment every month, every year. And then you have 30 years. Okay, so we want to find the future value. Again, this one says the effective rate is 10%. So entire per year is 10%. So we calculate the monthly rate J. 1 plus J to 12 is 1 plus I, which is 1.1. And from here you can get J. Once you know the J, let me write the numbers you need to enter. You have to enter payment is 100. How many payments? 30 times 12. Then the future value is what you want. Present value is 0. And then COY, POY is 1. And your rate is going to be J. Okay. As a percentage. Okay. So you can do the problem. Okay, so I'm going to skip these other problems so you can try it. Let me know if you need any help. So let's meet again with the continuously paying annuities.